Hello. How'd you like the last presentation? Good stuff? Learn a lot of the good things today? Sorry to just ruin it at the end and come here and just, be a downer and have black slides and all that. So, name's Keith Parsons. You can find me on Twitter at Keith R. Parsons. I like asking this question wherever I go. Something like, how many of you are not on Twitter? Okay, leave your hands up. Leave them up. I hereby swear. Serious, get on Twitter. It's where the Wi-Fi community hangs out. You can also reach me at WLANpros.com. So, I've taught hundreds of the WLAN design classes. And from that I learned some tips and tricks, and so I'm going to share a couple with you. So, a little bit of information about me, you can track me down there. So, to start out, Wi-Fi is easy to do wrong. In fact, the things that Yussi was talking about earlier on, 80% are bad Wi-Fi. The reason we have bad Wi-Fi is not because people don't know how to do it. Well, it's kind of a little, they don't know how to do it. It's they haven't been punished. The reason they haven't been punished is because if it was Ethernet and you cross pairs when you're punching down an Ethernet cable and you plug it in, it doesn't work. You're instantly punished and you figure out, that didn't work, I should fix it, and you fix it now. The why we have a lot of bad Wi-Fi is, it doesn't matter if you don't even know what you're talking about. It still works. You take an AP and you do everything wrong. You put it on the wall, you hide it the thing, you put the power, you put the power up, you put the power down, you're on the wrong channel. It still works. And so because there's no punishment, people continue to do the wrong things. So, let's see what are some rules we should follow and figure out what some best practices are. If we all can agree with these, then we can move forward and have better Wi-Fi. Here's an example of a rule. This is from Guy Kawasaki, and he says you should have no more than 10 slides, don't talk more than 20 minutes, and have 30 points on your slides. I'm going to break these rules. I'm going to talk I have more than 10 slides, and I'm going to talk more than 20 minutes. But I did try to keep the 30-point font, so we're going to go for a big font here. First, let's talk about Lego. How many of you play with Lego as a kid? How many play with Lego as an adult? Yeah. Okay, so you'll understand this. I grew up in Norway like a long time ago, right after Lego first came out. And so my mom would have other lady friends come over with, to have coffee cake or something. I don't know what ladies did. I was a little kid at the time. And she'd say, I had this lady come over. Can you play with her boy? I'm like, oh, no. I was going to do Lego after school today. She goes, you can have him come along. Oh. Have anyone ever had a friend who didn't know how to do Lego right? And so here's an example that I put together. And I've got some demos with me, but when you're playing with Lego, even when you're like 6, you learn some rules of how to do it right. Because if you do it wrong, things just fall apart. And that friend who comes over who doesn't do it right, you just like, oh, man. So let's say we had a set of requirements. And the requirements was, I need a house. It needs to look like a house. It's 16 by 8, studs, big house. It's 4 bricks high. We need the roof to be sloped, and we want it to go lengthwise, and you only have a little handful of bricks. Now this is way more complex than a kid would have, but I defined it. I could show you a picture of one, and someone else, and I could build a house, and my friend could build a house. Well, here's what happens. The people who don't know what they're doing can still build a house. Here is a house that meets those requirements. It is 16 by 8, 4 stacked high, has a roof, looks like a house. He broke the rules. Some of the rules about Lego are, you don't stack them straight up. Well, I wanted it to look pretty. I don't care. Those rules. So here's a simple rule. Same size, same look. The difference is I can stand on it. And the only difference, 8 by 16, 4 high, sloped roof, same thing. But it doesn't break. It doesn't break because it's built following the correct rules. I'll get it off the stage so I don't hurt myself. We need to engineer solutions, not just make them up. Wi-Fi is like engineering. And I like where UC was going this morning, how he started off. We need more people, and the people who are in it are stretched, and I mean, I'm on the road, I think I've got 270,000 miles so far this year. All the time. I don't want to travel that much. But there's a huge need in the people. So part of the problem is we look at our solution and not everyone knows how to do it because they don't have the rules. So let's go through some rules. Let's say you had, your wife says, can you build me a doghouse? You go down to the DIY store, you buy some wood, you maybe did a little bit of, drawing on a napkin, and you make yourself a doghouse. But she goes, oh, I don't like dogs. I want horses for pets. I need a big barn. You're not going to go to the DIY store. You're going to have to do trusses. Trusses need math. They need engineering. They actually have software to go and say, if I want to go this far, and I'm using a 2x6 truss, and I'm going to use this format, how far can I go? And we're over in Wi-Fi, and we have the same problem. When you go and put, here, I'll actually say the word out loud, a WAP. Oh man, it got hurt to say that. You put a router in your house, it works. Because of the first rule, it always works. Wi-Fi always works. Even when you do it wrong, it still works. And so people say, oh, how come we don't use those in our enterprise? It's because as you do Wi-Fi to scale, they're both made of wood. They both have a roof. But one needs a whole lot more math and engineering because it's at scale. Here's another example. I also came from the contractor trade, so I used contractor things. Both of these are using rebar. And in a minute, a couple weeks from now, you will not be able to tell. They're going to pour concrete over that, and it's just going to look like concrete. We install our Wi-Fi, and we could do a really good job, or we could do a really bad job. Either way, in the future, how are you going to tell? Only when it fails. And when it fails, you're like, how come this broke? Why is everyone saying we have slow Wi-Fi? Well, what did you put in? What was the infrastructure you started with? So let's go through some of these rules of what rules you should follow. And of course, you should break them. I have no problem whatsoever when someone breaks one of these rules. Totally fine. But if you're going to break a rule, you better know why. And if you understand why you broke the rule, I'm all for it. But if you don't even know what the rule is, you're going to be making some of that. Okay, here's the first rule. Coverage is easy. We teach a bunch of ECSE classes, and I think I say in 4 days, coverage is easy 50 times. You want coverage? Put another AP. You want more coverage? Add another AP. You want even more coverage? Turn up the power. You want coverage? We can do coverage whenever we want. 15 years ago, I thought coverage was the most important thing. Admitting things, I used to put on 30 dB amplifiers on APs so I could get more coverage. Yeah, obviously didn't know what I was doing. But I made really big green surveys. Engineer your designs. Don't use a marketing ratio. If anyone ever comes to me and said, well, in fact, I see RFPs or tenders come out going, we want to make sure we maintain really equality. Make every 250 square meters have another AP. Oh, that's like going into your architect, your building designer, and say, hey, yeah, in this room, I think we should have 4 beams per room. Why? Because I just like 4 beams. I think we should have 1 AP per classroom. Why? Does that have anything to do with any requirement? I don't know, but it's easy to say. Let's put an AP every 2,500 square feet. Let's put an AP every 3,000 square meters. Whatever the number is, if it's a ratio, I'm telling you it's wrong. Because you didn't engineer the solution, you just used a ratio. Know all your requirements. Part of the coverage issue is it's easy to know coverage. And it's easy to put it, and it's easy to measure it, and it's easy to do. But coverage is easy. It's also required Pause for effect. It is required, but it is not sufficient. We must have coverage, but it's not all the requirements. We need primary, secondary, co-channel interference, data rate, SNR, density. There's a whole bunch of other requirements we haven't looked at, and so that's why sometimes Wi-Fi fails, because we deliver the wrong thing. You cannot design for all clients. Customers hate this. You go into your clients, and your customer's talking to you, and the customer says, you ask a question, which client do you want your Wi-Fi to work with? And their answer is what? All of them. And I say, I can't design for all of them. What do you mean? Well, which one? Are you on a phone? Which phone? The Galaxy S3? S3 had a terrible Wi-Fi chip. If you want me to design for an S3, I'm going to have to over-engineer the whole rest of your entire infrastructure. Is going to cost you maybe 4x more if you make me design specifically for a Galaxy S3. You want an iPhone 4? Well, now I have to put in 2.4 gig. You want an S6? What device am I going to design for? Because I cannot design for all of them. It's not Ethernet, where I could take an Ethernet from 10 years ago and an Ethernet from tomorrow, and they'll work exactly the same. Wi-Fi chipsets change, Wi-Fi capabilities change, I have single stream, multi-stream, all sorts of things. So design for the Elsie Mi. Elsie Mi is a term from Devin Aiken first coined it, for least capable, most important. If you find the right one to design for, everything else comes along for free. If you pick the wrong one, there'll be holes and things won't work. You may purposely, with intent, negotiate with your customer and set the Elsie Mi above who's on your network. In fact, I hope you do. Because when your customer says, we want everything, and you go, oh, really? That's going to cost 4x. What's X? I don't know yet, but whatever you ask for, it's going to cost 4 times as much to go backward. They don't understand. It's not like a switch port where if I want more capacity, I buy more switches. If I want to change my client, it's going to change my entire design. Use the widest channels you can until you can't. In fact, I really like a whole bunch of rules that are do this until blank. If you don't know the blank part, the rule just sounds like, oh, it's a always do this. I say always use the widest channel until you can't. If you can't, then don't use the widest channel. But if you don't know how to tell if you can or can't, then you're going to be making mistakes. I've been asking, pleading, begging, on my knees, literally in front of someone, and said, could you please stop shipping 80 megahertz wide defaults? Would anybody like to have no more 80 megahertz wide defaults? I don't know of a single vendor who sells that has 80 megahertz wide defaults that actually recommends it. But they're like, well, if we don't, but they do, then we go to a head-to-head thing, they'll win and we'll lose, so we have to go wide. Why? What they don't understand is customers see a default and say, ooh, that's a recommendation. Why are you 80 megahertz? Oh, because my vendor told me to. No, they didn't. You can, though, until you can't. Well, how do you know you can't? You can't when you have co-channel interference. Because I would rather have two 20s that don't interfere with each other than two 40s that do, because then I don't have enough capacity. Two 40s that interact with each other have less capacity than two 20s. Choose the antenna you want that covers what you want, as long as you don't cover what you don't want. Because covering an antenna that you don't want actually causes more harm. Because Wi-Fi is not like cellular. Wi-Fi is an entirely different protocol. And so for a Wi-Fi protocol, what happens is, if I have an antenna that covers that room, and that wasn't my target, whoever's over there talking makes me stop. I wait for them to finish talking. So if my antenna just happens to go over here, I really want to talk to you guys, but I hear them, you get punished whenever they talk. That's an antenna choice. Let's choose the right antenna for what we want to do. Association is to wireless what a link light is to wire. This is like, should be tattooed on the inside of your arm. If you had someone who calls up and said, I have a link light, do you troubleshoot up the stack or down the stack? Okay, this is the part where I ask a question, you answer. If you have a link light, do you troubleshoot up the stack or down the stack? Why don't you troubleshoot down? Because it's working. And then we get over to Wi-Fi, and, oh, here's an example. Had a dorm at a big university, and some guy calls up, just think through this. He calls up and he's on a Ethernet port. And he says, I'm having a really slow time downloading my BitTorrent from some server in Sweden. Do you ever think of replacing his patch cable? Well, he's got a link light. He's sending data across Ethernet. It's hitting some switch. It's going out, and it's probably the BitTorrent, especially because you're probably blocking it. The same guy calls with the exact same excuse, but he's over wireless, and you go, oh, I wonder if we should give him a new access point. The same exact thought, it's layer 1. If he has an IP address, he doesn't have a wireless problem. If he's using BitTorrent at all, he doesn't have a wireless problem. If he calls in and says the Wi-Fi is slow, he doesn't have a wireless problem. When he says Wi-Fi is not working, that's a whole different, that's a wireless problem. We have to understand the difference between those two. So this is like, memorize it. Coverage is to wireless what connectivity is to wire. I'm too old to tell you this, but a long time ago I used to work on thicknet and then moved to thinnet. And we had this demo we would do with thinnet where I could take a chunk of not twisted pair, well it was twisted pair, barbed wire right off of a fence and send Ethernet over barbed wire. It went about 50 centimeters. That's all. But I could make Ethernet work at 10 megabits over 50 centimeters of barbed wire. It had infinite crosstalk, but it did have connectivity. Connectivity is required on a Cat5 cable. You have to have electrons flow from one end to the other. But just because you do, doesn't mean Ethernet's going to work. We must have coverage in wireless. I have to have RSSI hit your radio. But just because I do, it doesn't mean it's sufficient. We have to look at, again, all the requirements. If it moves, wireless. If it doesn't, wire. Okay, this, you laugh and you think this is simple, but so many of my customers go, yeah, we want to put in this little sensor device over here. Is it going to move? No. Why do you want me wireless? Well, it's cheaper. But why do you want it wireless? Anything that doesn't move, why do we want it wireless? It's going to cause other issues. If it's a budget issue, fine. Just make them pay for it. They think, customers, think that just because we have wireless, we can throw more and more things over this same infrastructure, but the infrastructure doesn't work that way. Always do a validation survey. Always. There's no doubt on this one. When do you test and validate Cat6 cable? When it's on the spool, on the truck, outside, or after you install it? Always after you install it. So why are we going and saying, yeah, I did a survey, an AP and a stick, something before. You're like, but you installed it? Yes. Survey again. Because you don't know what's happening if you don't do that. This should just be flat out required. Don't put access points in the hallways. Always do a passive survey. If you're using Ekahau will not allow you to do an active without a passive. You have to always do a passive. Applaud that. Don't put access points above the ceiling. If you're going to do an active survey, and I think active surveys are cool, you better know how to deconstruct the answers that it gives you. Because an active survey is going to show, every time you roam, it'll show failed pings. And you put that on a map, you have a little red area, and your customers go, oh, bad place. It's red. And there is absolutely nothing wrong with the Wi-Fi at that location. I happen to be walking this way today, and today I roamed here. So it's going to show red on the map. If tomorrow I walked a different way, it would show red over here. That's still a good Wi-Fi. This is still a good Wi-Fi. But when you show an active survey data and it has a red spot, bad place. Jason, it's kind of hard to show ping times exceeded 1 second and put that in any color that looks good. Don't put access points on the wall like a clock. If you do, Wi-Fi will work. If you hang them above the ceiling, Wi-Fi will work. If you put them underneath a chair, Wi-Fi works. If you buy a Soho device, Wi-Fi works. Wi-Fi always works. When a customer says Wi-Fi slow, Wi-Fi is also working. So don't use, oh yeah, Wi-Fi works, as an excuse for anything. If you really want to enjoy a little laugh, go to something like SpiceWorks and look at Wi-Fi people talking on there, and they say the dumbest things. They say, yeah, I read somewhere you're supposed to do this XYZ best practice. I didn't, and the Wi-Fi still works. Of course, it doesn't matter what you did, the Wi-Fi's still working. Use the highest possible transmit power. This is for Stephen. Until you can't. Now, sometimes the vendors will say, oh, you should match the power to the client, to the thing. One, you're going to sell a whole lot more APs. Two, if you can use transmit power until you can't. But if you don't know when you can't, and rather than teach you the correct way to measure it, they just say, oh, don't use high transmit power. There's nothing wrong with high transmit power as long as it doesn't harm the Wi-Fi. If you end up going slower, it's harmed the Wi-Fi and you shouldn't use it. I'm advocating whatever the rule is, what anyone says, be able to measure it and figure it out. Never use a captive portal. Okay, this one. There is no. You note there isn't a do this until. This is just don't do it. Because customers want fast, free, and frictionless. Anything you do that takes away from that takes away from the customer experience. I don't know why anyone would want to do that, unless you sell captive portals, and then maybe you'd like to do that. Always use DFS channels. Again, until you can't. But if you don't know how to measure and see your log files and track down and say, this didn't work because, then don't use them. But if you don't use them, then you're going to cause co-channel interference on the other one, and everything else is going to go slow. So all of these are just simple rules if you understand the criteria. Design for 5 gig. My recommendation is if you do that, then turn off 2/3 of the 2.4 radios. Or 3/4, or 5/6, or something. It could be half, whatever, but that's 2 separate designs, 2 separate requirements, 2 separate worlds. I'm going to design for 5, and as an afterthought, I'll throw 2.4 in. Use only 1.6.11? Yeah, I could have put in here until you can't, but you can always use 1.6.11. Place access points close to the clients. A lot of other people today have said that. I wish I could put them all at waist height. Put your APs literally as physically close to your clients as you can. Now, when you can't, it's probably something like they're going to get vandalized. People are going to kick them. But realize physical closeness will make them go faster. Choose your access point before you design. Here's an example. I pulled this from Ekahau. Here are 6 different APs. They are all sold into the same marketplace, and they compete with one another. And I took away the vendor names, so I'm not trying to be vendor bashing at all. I'm just saying these are the antennas that are used. This one has a negative dBi. I transmit at 10 dBm, I get less than 10 out. I can pick up about 2.2. This one right here, gotta get your arms back. This is 100% of people. Put your arm up here. Arms to square, everyone. I swear, I will never use the generic AP again. You cannot buy one. Why in the world would you ever want to design for one? Because it will always fail because it doesn't match. You can't buy it, so you can never get one. It's perfect, by the way. Look how perfect. That's kind of weird, but yeah. I thought it would have been a perfect donut thing, but no, they had to do some little spiky thing. But if you look at these, there's a difference from a negative up to +8, almost +9. If I'm going to go design this, it's an entirely different design. Which AP am I going to choose? One of the reasons not to use generic is you can't buy one. Another reason is you think if I design with generic, then I can swap them out. They are not swap-outable. I don't know if that's a word, swap-outable. Changing the number of APs may change your capacity. May, and this is a big may. People think, if I have a capacity issue, I need more, throw another AP. Most of the time, it's not going to help. So, 2 access points, same channel, have CCI, have the capacity of 1. So if I have 2 APs and they see each other, they only have the capacity of 1. So it doesn't matter what you do with your capacity planner, you use Andre Van Age's planner, you're in Ekahau and you use capacity planner. If you have co-channel interference, you don't get to count them both because they're sharing in the same collision domain. just the slide for what is co-channel interference. But if you change your client, you are guaranteed to change your capacity. Now let's talk through this. Not everyone understands this. I'm going to show it's math, sorry. Let's go. So if I have an access point, it's a 2x2, 300 megabits capacity. This is kind of an old slide, but the numbers will be telling. And then I have a tablet that's a 1x1. It can do 65 meg raw, netting about 30 TCP. So if my application needs 2 meg, that's each tablet uses 2 meg. They work at 30 megabits per second, so each tablet will use up 6% of airtime. If I have 200 tablets times 6% airtime, I need 13,000% airtime, or basically 14 air times 14 radios. So if I have 200 tablets and I want to give them all 2 meg apiece, I need 14 radios. Now I call it air times for a reason. Now if I, instead of having tablets, I use laptops. They do 300 raw, netting 150 TCP. Same AP, APs don't change at all. Same application, 2 meg, same math. Each one now is only 1.3% airtime because they're faster. The laptops use less air because they talk faster. Divide the whole thing back out, and now I get 3 air times. Tablets, 14. Laptops, 3. When you go to your customer, they say, oh, I want you to design for everything. Really? Do you want me to put in 14? That's a big price difference. Oh, we want a mix. Okay, let's look at a mix. If we do a mix of 100 tablets and 100 laptops, instead of 14 all tablets, 3 all laptops, we net 10 for the mix. That's at 50-50. Your client decision is going to change your entire design. It's not about where you put APs. It's what am I designing for? And most people just totally forget this. So, backing up. Do one more. I clicked way too many times. There you go. Changing your client device will, 100% of the time, change your capacity. APs may. Okay, let's see if we can get caught up here. I say use top-line APs. Every vendor makes the top-line AP. They try their hardest, they put the most R&D into it. It may be a 4x4x3 or a 4x4x4, but they put the best components. All the pieces are best, but it has a high COGS, cost of goods sold. And then when they're done and they've proven this best-of-breed AP, they sit around in a meeting and they look at it and say, what can we do to lower the price? Well, we have to lower our cost of goods sold. What can we take out of an AP that we just designed to put our heart and soul in to be really good and make it worse? Literally, they sit around the room and say, what can we do to make this AP worse than what we know how to do? We know how to do good ones, and we proved it. Let's see if we can save some money. And then they do a 3x3, and then they do a 2x2, and then they do really super cheap ones. Along the way, they have to take out cost, which means every component gets worse. So why in the world would I ever want to install an AP that was purposely designed to do worse? It's just about money. And you know what? 4x4 top-of-the-line APs outperform 2x2 APs. Duh. They outperform so much that you actually save in TCO. The total cost of ownership goes down when your AP price goes up. I need fewer of them. Fewer license costs, fewer install costs, fewer switch ports, fewer cable pulls, and the net effect is I have saved TCO when I don't buy the cheap AP. Think about it. Okay. Lowering the transmit power does not fix CCA issues. I'm sorry, everyone who likes to say, oh, I have co-channel interference. I want to turn my APs down. All you have to do is fire up Echo, look in, take an AP, change its power, and you go, oh, wait. I changed the power by 100 times, and I maybe lopped off 10, 20% of my co-channel interference zone. You want to get rid of co-channel interference? Turn off a radio. Turning up the power gives me a one-way improvement. Changing my antenna gives me a two-way improvement. You want to improve your Wi-Fi designs? Use different antennas. Know your protocol. Where's Peter? Whoa, this one's just for you, Peter. If you don't know the protocol, how can you possibly fix what's going wrong? You have to know what's going on, or you're going to have to believe what any sales and marketing guy tells you. Double the distance, quarter the power. This is just one of those things that you need to have memorized in your head. Quarter the power is 6 dB. If I want to go twice as far, I have to add 6 dB. Also, 2.4 gig and 5 gig, they go the same distance. Has anyone in this room ever said, well, 5 gig doesn't go as far as 2.4? Be honest. I say it all the time. It's a flat out 100% lie. If I send a 2.4 and a 5 gig radio at the same time here, boom, they would hit the moon exactly the same time. They would hit Jupiter exactly the same time. And 7 years from now, they would hit Alpha Centauri at exactly the same time. 2.4 and 5 gig go exactly the same distance. The difference is totally in receive aperture. The 5 gig has a smaller antenna that's tuned to 5 gigahertz, and it receives less energy than 2.4. It will always receive less energy than 2.4. So don't mistakenly say, it doesn't go very far. It actually goes the same distance. The difference is on the receive side, I didn't grab enough energy. So how do we fix it? You make the 2.4 6 dB less, you make the 5 gig 6 dB more. In fact, it's my choice, I'd go 6, maybe 10 dB higher on the 5 gig because we want people on the 5 gig. Know everything about your clients, not just your MCS and your data rates, but your IP address and the throughput and all the numbers. Know the difference what's supposed to be on the wireless, what's on the wire, and how to compare those instantaneously. Let's look at the screen for a second. This is a hotel in Dubai, right next to this place called Silicon Oasis. You know, we have Silicon Valley, Silicon Oasis. Yeah, I'm on a network here. I'm getting MCS 9, fantastic, great SNR, pretty good noise, signal, great. I'm on channel 157 with the 8 megahertz channel, and I am pulling down 867. That is the max that AP can do. Well, my laptop can do better, but as good as the AP could do. I cannot make the Wi-Fi any better. And look how stable that MCS is. This is good RF. How about my internet?
Well, that's Middle East. It's normal.
That's normal. What does a customer say when they have this experience? The Wi-Fi is slow. Is the Wi-Fi slow? Can I prove it? Wouldn't it be nice if we had an app that somehow ran on the computers that when customers went, oh, I think my Wi-Fi is slow, they hit a button and it shows, Wi-Fi is this, DHCP sucks. You just told them right up, your DHCP took 27 seconds to respond. That has nothing to do with wireless. Or what if it goes up and says, the Wi-Fi is slow, and it says, really? You're getting MCS 9, and they don't need to know what that is. We just show green. You have good RF. You have bad backhaul. You, as industry specialists who's supposed to know this, you should be able to do this in literally half a second. Okay, maybe 2. But you should be able to sit down at any machine, your machine right now, your laptop, your handheld, anything, and go, right now, boom, what's my RF, what's my backhaul? They are 2 different things, they have 2 different responses, and we fix them 2 different ways. Would adding any access point make this any better? Would it buying Wave 4, Wave 17, Wi-Fi 7, anything we could, that cannot make this any better. In fact, if I went all the way back to 807B, it would still be said the Wi-Fi is slow. It's not about the Wi-Fi, and you need to know the difference. I think you should use professional tools. I'm a professional tool kind of guy. I like gadgets, but I think if you have the right tools, you can solve the problem. You would not expect to go into a surgeon and have them, well, I did once. I was in an accident in China once, and I go in to get my head sewn up with stitches, and the doctor shows up, and he gets out a fish hook. Literally a fish hook, even smelled like fish. And he goes, oh, I should clean this. So he got a little emery cloth, and he's cleaning off the rust. Yeah, I wasn't feeling really confident about that surgery right then. If you show up and you go, oh, I have Insider. Insider's a great tool. It is not a professional tool that we should be using. Yes, it gives you information, but it's not a tool that we need to pull off. If you show up instead of with a laser rangefinder, you show up and you have a ruler and you just fold it over and over when you need to measure the rule, yeah, use the tools that you need. I'm not going to go through the details on this, but you should be able to have, I know you're not going to have this memorized, but you should understand this MCS table and say, if I connected at 866 and I went data no ACK, data no ACK, data no ACK, fail, where am I going to go? Does my client climb up? Does my client move over? Do I go 866, fail, 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 whoop, all the way to BPSK? And if so, why? Why is my client acting this way? Why does my AP travel this up and over? Because every single transmission, whether it's AP to client or client to AP, at every frame is going to make a decision on how do I package it. Do I package it with a 256 QAM and a 5/6 coding with a 40 megahertz wide channel, a short guard interval? And it builds that frame at the PHY layer to do that. If it works and it sends it and it receives ACK, it goes, that was a good one. I think I'll try that one again. But frame by frame by frame, it's making these changes. You need to know how your clients, how your APs, what's their process of going through there. So when a client says, yeah, I'm stuck here, I keep going MCS 4, 5, 4, 5, well, that means your QAM is flipping back and forth. What can I do to help that? Is it because it has, my SNR is just off? Or is it because I'm in the wrong place, I don't have enough? One table can let you figure those things out. You also need to know which channel you are and what country you're in. Your countries change these rules. I think I've got this as of the last Ofcom update, but we're going to get new ones in the US coming really soon. Again, don't memorize it, but just find you have the right one. Left side, a whole bunch of rules for requirements that have to do with RF. You might do those inside ECHO. The ones on the right are things that you would do in your vendor. So if you have a vendor specific one, you do the ones on the right. And that's it.